Alright everybody, in today's video we are going to be using a double pole double throw switch to control two devices at two separate voltages. So this is really cool, right? So at the flip of a switch we'll be able to control two separate circuits, activating both of these at the same time, or if we wanted to we could even have them offset. So where the switch is off, one of them is on and the other is on, and vice versa. So this is my first time going over LEDs on this channel, so I want to explain that. And right here, this resistor, the purpose of this resistor is to limit current so that we do not have too much going to the LED and destroy it. Why do I have a 1.5k ohm resistor? That's just what's in the Radioshack unit, and I'm duplicating that. So that's how I got this value. We don't need a bunch of current to turn this on. I can reduce this to 1k or 500 ohms or even less, and the bulb will burn brighter because it will be receiving more current. It's just not necessary in our application. We just want to see it illuminate, right? That's the goal. So here's an LED, a drawing of one. And the best, so there's two sides to it. And it does matter. Polarity does matter on these guys. So one side will be the anode, the other cathode. Anode positive, cathode minus. How I remember it is, here's the schematic drawing. It's made up of like two parts. One is a line and one is a triangle. The C in the cathode can easily roll out to be a line. Minus, I kind of just view it negative, minus, line. So this is going to go to ground, the cathode. Anode starts with A. A's have a triangle on the top of them, and so that's where that goes. And if this side is negative, then this side will be positive. And the component itself has a flat spot on one of the sides. So again, I associate that flat with a flat line. So I know that that's the cathode side. So that's LEDs quickly for you. Let's go ahead now and look at the simulation portion, and I'll also show you the current limiting resistor inside of the Learning Lab kit to show you where I got this 1.5k from. All right, let's take a quick look here at our Learning Lab kit. Up here are our LEDs. So when we open this up here, you can see the schematic too. And now you know how to tell which one's the difference between the anode and cathode side. You can see, according to this, goes so your input, your current limiting resistor into the anode, out of the cathode, and then this will go to your ground. But okay, let's go ahead and open this. And you see R1, R2, R3, R4. These are our resistors. These are called surface mount resistors. And you see the number on it. I'm looking at R2 right here. You see a 152. That means 1, 5, and it will be followed by 2 zeros. So 1500, 1500, or 1.5k ohms. And on this kit, all the surface mount resistors are the same. Alright, so let's get into the simulation portion of this lab. I have it all set up here. You're going to notice a couple things that I'm now doing differently going forward, I'm going to reduce the amount of current we're using just because there's no point in doing it. You know, we want to keep things safe. Let's keep things lower power, the better. So I went ahead and I changed all of our resistors from, I think I was doing 10 ohms to now 1000 ohms. Let's just see where this takes us. You know, we're all just experimenting here. This may be too much. We'll just, you know, let's see what happens. Let's have some fun with this thing. So what we're looking at here is still our same 6 resistors to give us the different voltages. And then here's our double pull, double throw switch. And we have a buzzer and we have an LED. So one thing I added was this current limiting resistor on the buzzer because, remove this. As you'll see, there's a lot of unnecessary current going to this. So let's see what happens when I turn this on. Let's hit play. Okay, and stop the annoying noise. So our buzzer was getting our 9 volts, and our LED was getting our about 3 volts and 180 milliamps. And that's just, you know, a little unnecessary. So that's why I put that limiting resistor on there. And if you notice, the LED did not turn on. So in simulation, we can control a lot of these things. So this LED is programmed to not turn on until it exceeds 800 microamps. And right here, as you can see, we're getting just under 500. So that's why it's not turning on. But the real world is different, right? So it's cool to simulate, but it's not always so analogous like the real world. I can change this to be like, you know, whatever we want here. I can do 400. And now it's saying that the LED turned on, you know? So we don't need this much current. So I am going to add a current limiting resistor here. Because why not? And to just keep things easy, I'm just going to keep it the same, 1.5K. And now when I run this thing, notice no noise, and we're getting about a third of the current that we were getting before. No noise. You know, this, again, that's something that can be configured in the settings. So this is 10 milliamps, and we're only getting 5.8. So that's why it's not turning on. What? Okay, that's our circuit. Now that it's working in our simulation. Oh, I also, real quick, I did bump these resistors not only up to 1K ohms, but they are now half watt resistors. Something else I did. So, okay, let's go ahead and continue onto our hardware build now that it's working in our simulation. All right, real quick before we proceed, say hello to Benjamin. Being a good boy. Yeah. All right, so I did have to kind of do something to this switch to make it work for this. So, okay, first of all, I changed all these out to the half watt 1K resistors. And then I had to basically solder on each leg of this double pull, double throw switch to make this work. I kind of did yellow for our source, red for our off state connection, and green for our on state connection. and then I heat shrinked it just to protect it from shorting. But why I had to do this is because before we were using these micro switches, right? So let's say this red one represents our 3-volt source. So we can go in here, right? On one side switch, and this blue one represents our 9-volt source. So we can go to this side. What's wrong with this picture right here? What's wrong with that? Pause the video and tell me if you can. Do you see what's wrong with that? On the breadboard itself, this whole row is electrically connected. So our 3-volt source is connected always to our 9-volt source. So whatever this is going to be connected to, the output, we'll just get the 9 volts instead of the 3 volts. We don't want that. And for some reason, it doesn't exist. I cannot find it. A double pole, double throw switch that will just sit right here in between on the breadboard to isolate one side from the other. I don't know why it's not a thing. Somebody should manufacture one. So I did that. That's why I had to do this. So now I have one side of the switch isolated from the other side of the switch. So now we can do our separate voltages. I'm going to do 3 volts on this side, 9 volts on this side, but that's what you're looking at here now. All right, let's get into constructing this thing. I'm going to start with the bottom circuit. So we'll bring 3 volts into the switch and then out of the switch to our current limiting resistor. So let's bring 3 volts in. And I don't know, let's go to here. Output will be our 1.5k ohm half watt resistor. Okay. And that is going to go into our anode side of the LED. So anode will not have the flat part. So so anode will be this side. Okay. And now we can just ground from our cathode, bring our cathode to ground. Okay. And then I'm just gonna go ground to ground connection like that. Okay. So now that circuit is all complete here. Let's move on to our other one. So we'll have a 9-volt source going into the other side of our switch, into the positive side of the buzzer to ground. But we are still going to add a current limiting resistor to that. So it'll be quieter, less annoying. I like it. So let's bring our 9 volts into this side. Put that down. And then we'll go output. into current limiting resistor. And then put in our buzzer. Okay. Can you see all that? Okay, so right now we're disconnected from our power. Power switch is off. Double pull, double throw switch is off. So let's go ahead and off. Plug it in. No, double check connections. The buzzer is always finicky. Okay. Lines up good. Okay. Cool. Alright, now I'm going to turn on the power. And now when I flip this, I'm going to get the buzzer and the LED to come on at the same time. And there we go. Cool. Works. There we go. We controlled two devices at two separate voltages with one switch. Now, if I wanted to, just for the thrill of it, let's turn everything off. Let me bring the LED output side, the 3 volts, into the off state. So now they'll be offset. When this is on, this device will be off, and when this is on, this device will be off. Let's turn this back on, and LED is on. And now when I turn this on, this will go off, buzzer will go on. Cool. And that is how you use a double pull, double throw switch to actuate two devices at two different voltages. Cool.